So the question is, consider the following message, and the message is given like this. In the question, the cyclic redundancy check for this message using the divisor polynomial is given like this. You can do it easily. 1 into x to the power 5 plus 1 into x to the power 4 plus 0 into x to the power 3 plus 1 into x to the power 2 plus 0 into x to the power 1 plus 1 into x to the power 0. So by doing this, what we are getting? By doing this, we are getting CRC generator bits, that is 1 1 0 1 0 1. This is our CRC generator bits, and if you are going to collect CRC generator bits, it is 1 1 0 1 0 1, right? This is CRC generator bits. Now, how many length it is? 1 2 3 4 5 6. So we need to append 5 zeros. We need to append 5 zeros at the last of message. What is our message? 1 0 1 0 0 0 1 1 0 1, and append 5 zeros. 1 2 3 4 5. This is appended bits because CRC generators are of 6 bits. So 5 bits we have appended. So after doing so, what we can do, we need to perform XOR operation with the help of CRC generator. 1 1 0 1 0 1. So 1 1 0 1 0 1. If you are going to perform XOR operation, 1 1 is 0 1 0 0 1 is 1 1 1 0 1, and 1 1 0 1 1 2 3 4 5 as it is copied, right? Now here 1 1 0 1 0 1, and perform bitwise operation. So what you can get here, 1 1 is 0 1 1 is 0 1 0 is 1 0 1 is 1 1 0 is 1 1 1 is 0 1 0 1, and 1 2 3 4 5. Now again, if you are going to see 1 1 0 1 0 1, so 1 1 is 0 0 1 1 1. Just a second, 1 2 3 4, it is 1 0. So right, 1 1 is 0 1 1 is 0 0 1 is 1 0 1 is 1 1 0 is 1, and 0 1 is 1, and rest 1 1 2 3 4 5 as it is. Now again 1 1 0 1 0 1, so you can see 0 0 1 0, and what is 1 0 1 1 0 1 1 2 3 4, right? So let me do here, it is 1 0 1 1 1 2 3 4, and 1 1 0 1 0 1. So 1 1 is 0 0 1 is 1, and 1 0 is 1 1 1 is 0 0 1 0 0, again 1 1 0 1 0 1. So 1 1 is 0 1 1 is 0 0 0 is 0 0 1 is 1 1 1 0 1 1, and 0. So you can see at the last we got how many bits we require? 6 bits. So 1 2 3 4 5 6, 1 2, just a second, how many bits we are having? CRC generators 6 here. So in CRC we only need 5 bits. So here we are having 6 bits. So here we need 5 bits. 0 1 2 3 4 5, right? 0 1 1 1 0. It is our CRC bits which is asked in the question. Option A is the correct answer. 0 1 1 1 0, and here also we got. So what is the process? Original message plus we need to append some bits. That bits are n minus 1, that is CRC bits are 6, so we have appended 5 zeros and performed XOR operation, that is also called as modulo to sum method. So by performing that at the last, because right now you can say that we can skip this left hand side 0, so what we are going to get 1 1 0, only 4 bits, and our CRC generator is of 6 bits, so we need to count 5 bits because CRC generators are CRC bits are just one lesser than CRC generator bits. So as a final answer you can say that option A, that is 0 1 1 0 1 1 1 0 is the correct answer, right?